Alright, up next we're going to be talking about solving exponential and logarithmic equations. Before we jump into that, I want to remind y'all about the change of base formula. The only logs that our calculator will compute are log base 10 or natural log. So if we have a log that has another base besides 10 or e, to compute it in our calculator we need change of base formula, which tells us if we have log base a, we can compute that by using log x over log a or natural log of x over natural log of a. Alright, so let's talk about solving exponential equations. Look at these three examples and see what you notice that's the same between all three of them. Did you get it? All the bases are the same. So in order for us to solve exponential equations, we need to have the same base. Using the information we just found out, on the next slide is an example. I want you to pause this video and try to work the example. In this example, we need to remember one of our laws of exponents. When you raise a power to a power, you multiply. After you've done all that, you should have got x equals 17 over 9. Now what happens if we don't have the same base? Believe it or not, the world will not end. Take a look at this example. We have a base of 2 and a base of 4. But if you think about it, 4 is the same thing as 2 squared. And then we're just raising a power to a power again, so we'll multiply. Now it's your turn to try one of these. Alright, so we know 4 cubed is 64. So we'll just substitute that into 64 and solve them like we have been solving them. Let's try another one. Alright, so we know that 3 cubed is 27 and 3 squared is 9. So now we have a common base of 3. I know it's difficult to think about, but what if it is impossible to get the same base? So we know how to solve the top one just like we've been doing, but what do we do about the one on the bottom? Well, how do you solve all of these problems for x? We will subtract on the first one, divide by 4 on the second one, and raise both to the third power in the third one. Those are all inverses, so it seems like we should have to take the log if we're trying to solve an exponential equation. Alright, in this one we have two different bases. We have a base of 2 and a base of 3. So let's take the log of both sides. When we do that, we have an exponent, which tells us we need to multiply because it's power to power. Then you just divide by log base 2, and you get it's approximately 12.68. See if you can do this one. The thing to remember in this example is that the inverse of a base e is the natural log, not just regular log. How about this example? You try it. Well, the first thing we want to do is get our exponential function by itself. After that, we can take the log of both sides, and then use our law of exponents to solve the rest of the way. That was a short, summed-up version of how to solve exponential equations and logarithmic equations. Be ready to practice in school on Monday.